This is the Charlie clock. While it's not working right now, originally this screen would show the hours, this the minutes, and this the seconds, and finally the display would show the date. It's in this 3D printed enclosure, and the user can change the time by the use of a rotary encoder, which is attached to this spinning object here. As the user spins through, they can change the time using this rotary encoder. Here's an example of the time working on the Charlie clock. And here's an example of the date working correctly. CharliePlexing, named after engineer Charlie Allen, is a method that maximizes the efficiency of digital pins in controlling multiple outputs. Using a combination of high, low, and high impedance states, CharliePlexing allows you to control a large number of LEDs with fewer pins than traditionally required. In most setups, each digital pin can be set to either a high or a low state, but with CharliePlexing, there's a third option, the high impedance state, otherwise known as input. This prevents current from flowing and offers a major advantage when controlling LEDs. Using CharliePlexing, we can control N pick 2 LEDs with just N pins. This means that 4 pins can control 12 LEDs and 12 pins can control 132 LEDs. As you can see in the diagram, 4 lines control 12 LEDs, which is the maximum possible number in this system, as it is 12 pick 2. In a CharliePlex system, lines that aren't meant to light an LED are set to high impedance, which stops current from reaching undesired LEDs. For example, to light LED 1 in the diagram, lines A and B are active, while C and D are set to high impedance or input, keeping other LEDs off. The Charlie clock uses 132 LEDs arranged in a circle with LEDs representing hours, minutes, and seconds in a CharliePlex configuration. 132 happens to be 12 pick 2, and it's also 60 plus 60 plus 12, or 60 minutes, 60 seconds, and 12 hours. The outer ring contains 12 blue LEDs for hours, the middle 60 green LEDs for minutes, and the inner ring 60 red LEDs for seconds. All of these LEDs are controlled by just 12 digital I/O pins, thanks to CharliePlexing. The Charlie clock is controlled by an Atmega 328P, which reads the time from the DS1307 real-time clock module. The MCU displays the time on the Charlie clock LEDs and updates it using the RTC's built-in 1 Hz square wave attached to a pin change interrupt for precision. The Charlie clock uses surface mount components, which are more compact but also more difficult to solder. For this, a stencil and solder paste are applied to the PCB before the components are placed. Then the entire board is heated in a reflow oven to solidify the solder. During the reflow process, the board is gradually heated to bond the solder paste with the component pads. Once baked, a fully functional and compact PCB is obtained. Thanks for watching. I hope you enjoyed this project video.